Here is the circle with center O, and if I take 2 points on the circle like P and Q, I get an arc PQ. Now this arc PQ is a minor arc because it is less than a semicircle. And if I join the point P to the center and Q also to the center, here I get this angle, the central angle. So the angle I get here is POQ, and this angle is said to be angle subtended by arc PQ at the center. Now for the same points P and Q, I get a minor arc, and I also get on the other side a major arc. This PQ is a major arc, and it is major because it is more than the semicircle. So here I have major arc PQ. Now this major arc PQ also subtends a central angle. Now let us mark the central angle. For that I have to join P to O and Q to O. So this angle here that I have is the angle subtended by PQ, major PQ at the center. Now I call that angle a reflex angle POQ. So reflex POQ is the angle subtended by major POQ, major arc at the center. So here we have learnt how to spot out the angle subtended by arc at the center. Now we learn angle subtended by the arc on the circle. So here again I have a circle with center O. I take 2 points, say P and Q, and this is P, this is Q, this is the minor arc. And if I now join O to P and O to Q, I know this is the central angle. So we have angle POQ is angle subtended at the center. Let us see which is the angle subtended on the circle. Now for this I take a point on the circle. So suppose I take now a point here P, which is on the circle, and I joined P. I'll take it as A. I've already taken P, and I join PA and PB. So here this angle is the angle subtended by the arc at the circle. So angle PAQ is angle subtended at the circle by arc PQ, the minor arc PQ. Now again, if I take P and Q, this will be the major arc, the arc more than the semicircle. And the angle subtended at the center, to draw the angle subtended at the center, I join. So this reflects POQ. Here a reflex angle POQ is angle subtended at the center. Subtended by major arc PQ at center. Now to find the angle subtended by the arc on the circle, we've got to take a point on the circle here. We call this point B, and then we have to join the ends of the arc to this point. The angle, this angle will be the angle, that is angle PBQ, angle subtended by major arc at the circle. Here we'll see a relationship between the angle at the center and the angle at the circle. So I have points P and Q, and this was the angle at the center. So I'll write it as angle POQ is the angle at the center. And to draw the angle at the circle, I need to have to take any point on the circle. I mark this point as A, and I join. This is the angle at the circle, on the circle, subtended on the circle. Now what is interesting to note is, if this angle is taken as x, the measure of this angle is 2x. It's double. So here the relationship, I can write that POQ is equal to 2 times of angle PAQ. So central angle is 2 times angle at center by the same arc. Let's take another example. Suppose I have 2 points. I'll mark the points, say PQ. This time I'm going to take the major arc. So I join this. So I'm going to take now this major arc, the arc which is more than the semicircle. And here is the angle at the center. It's more than 180, so we call it reflex angle. This is O, POQ. Now if we want to draw the angle at the circle, we've got to take a point in the circle. We'll call this point, say B, and then we join. So this angle that we form is called the angle at the circle. And the angle at the center is always 2 times the angle at the angle at the center is 2 times the angle at the circle, which means if this is like y, this will be 2y. Here's another property we need to know, is if we have an arc, we call it AB this time. And let's draw the angle at the circle. So here I'll take a point, say A. So this arc subtends this angle AB, or no, I call it P, I think. So I join here PA, PB. This is one angle subtended at the circle. Then if I take another point, say another point Q, I can draw another angle. Then if I take another point R, I will draw yet another angle of the same arc. If I take a point, say S, and I can draw yet another angle. These all belong to the same, in the same arc A and B. And what is surprising is all these angles are equal. This angle will be equal to this angle, will be equal to this angle. This is called angles in the same arc. Angles in the same arc are equal. So this is one property that we're going to learn. And we're going to learn yet another property. If this is the center, and here we have the diameter, say the diameter is AB, and we take a point on the circle. So if I join this, I'll get here angle in a semicircle. I'll call this P. Now the angle in the semicircle is always 90. So angle APB equal to 90. Here too I can draw on the other side too. If I take a point out here, I'll name it, say, Q. Here, this is again angle in the semicircle, and this also will be 90. So angle AQB equal to 90, because the reason, angle in semicircle. In figure 10.36, A, B, C are 3 points of the circle with center O, such that BOC is 30 and AOB is 60. If D is a point of the circle other than arc ABC, find angle ADC. So here the circle, O is the center. Let us darken the angle at the circle, at the center. So this is the angle at the center. So I'll just write this angle subtended at the center. Which is angle AOC. Now to denote the angle at the circle, so here's the point of the circle, and now I darken this. So this is the angle at the circle. So angle subtended at circle by the same arc, that's the arc AC, angle ADC. And we've already learned that if this is x, this will be 2x, or the reverse, if this one, say, is A, this will be half of it, A by 2. Here we got to find angle ADC. So angle ADC is the angle at the circle, and that is always half of the angle at the center, and the angle at the center is AOC. So angle ADC equal to half of the AOC. We've seen AOC is 60 plus 90, so that is half of 60, plus 30. So you have half of 90. So angle ADC equal to 45. So when this angle here, this full angle, just color the whole thing up, is 90. This angle will be 45. Reason, angle at the center is double or twice the angle subtended at the circle. Once again, so we have here is the angle, central angle, and this central angle is 90, and this is our angle at the circle here. So here this will be 45 degrees, half of it. Both these angles belong to the arc AC. They both start from AC. So when you mark from A, you come to the center, you get the central angle, and from both the end points you come to the circle and you get the angle at the circle. A chord of a circle is equal to the radius of the circle. So let's draw. Here we have a circle, and this is the center, we call it maybe O, and we have the chord of a circle which is equal to the radius. So this is my chord, and this chord is equal to the radius. Here is my radius, OB, OA is my radius. So all these are equal. I have an equilateral triangle. So chord AB equal to radius OB, and this is also equal to radius OA. So in triangle OAB is equilateral, all sides are equal. And in an equilateral triangle, we know the angles are 90. So let's mark the angle. So I have this angle, these three angles will be, not 90, will be 60 each. But here we are interested only one angle, that is angle AOB equal to 60, because it is an angle of an equilateral triangle. So this is 60. Now here I have two arcs. On this side will be the major arc, and here I will have the minor arc. Now the point here, the D that I take, D is the point in the major arc. So the angle which I join now will be the angle in the major arc. So I'll write angle ADB is angle in major arc. And now if this is 60, we've learned the property. If this is x, this becomes 2x. Or if this is, say, x, this will be x by 2, half of it. Now in this case, we know this is 60. What do you expect this angle to be? We expect it to be 30, half of 60. So let's write that up. So we have angle ADB equal to half of angle AOB. And we know AOB is 60. We have shown here angle AOB is 60 because it is a part of an equilateral triangle. So angle ADB will be equal to half of 60, that is 30. And this is the angle in the major arc because D was in the major arc. So we found this angle in the major arc. Now let's go ahead and find out the angle in the minor arc. Now earlier we knew this angle AOB was 60. Now if AOB is 60, what will be reflex AOB? This is reflex AOB. So let's write that up. We know angle plus reflex angle AOB equal to 180. Now AOB is already 60 plus a reflex AOB, it's not 180, it is 360, right? It's a full circle, so 360. So reflex angle AOB equal to 360 minus 60, and this is 300. So this angle now comes 300. And remember, this is the angle at the circle. Now what will be the angle at the center? This is the angle at the center. Now what will be the angle at the circle? So find the angle at the circle, I've got to take the point in the minor arc. This is the minor arc. And now I've joined it up. So if this is 300, here should be half of 300. This angle is half of 300, which will be 150. So the angle in the minor arc is 150. So let's write that. So we have angle A. I will put this as SC. So ACB is half of the central angle, and the central angle is AOB. So half AOB reflects AOB. There are two AOBs here, reflects. So that is reflex AOB was 300. So it will be 150. So angle ACB equal to 150. And this is the angle in the minor arc. To go with the sum again, first we found that this angle was given to us as 60 because it was a part of an equilateral triangle. And from there, see, this was AB, right? This was given as 60. This was angle at the center. Then to find the angle at the circle, we just took another point here at the circle, say D, and then we joined it up. This was angle at the circle. If that is 30, 60, this will be 30. Then we got on to this angle. This angle became 360 minus 60, and that is reflex angle. So this was 300. If this was 300, this was angle at the center of the same arc. The angle at the circle would be this angle here, starting from the same point C, B and C. So this angle would be half of it, and that would be 150. So from this point A, you come to the center, you get the central angle here. From the same point, you go to the circle, you get the angle at the circle. In the figure, PQR is 100, so let's mark that. So this angle here is given as 100, where PQR are points on the circle with center O. Find OPR. So if this angle is 100, PQR is 100. Now you know PQR is angle at the circle. So angle PQR is angle subtended by the arc at the circle or on the circle. Now how to find the angle subtended at the center? So from P and R, we join to the center. So this angle will be the angle at the center. So we'll write this. So angle P, this is O, R is angle at the center. And we know always angle at the center is twice the angle at the circle. So angle POR will be 2 times 100, and that will be 200. So we got this as 200 because this was 100, here we got 200. Now if POR is 200, we can find its reflex angle. Here is its reflex angle. So let's go to that now. POR is second step. Angle POR is 200. Therefore, reflex angle POR will be 360 minus 200, and that is 160. So here we have angle 160. So now we said this angle was 160, so let's write it. Angle POR equal to 160. Now look up at triangle POR. In triangle POR, we have two sides equal. We have OR equal to OP, and they are the radii. So OP equal to OR radii of the same circle. If the sides are equal, then the angles are equal. So this angle here will be equal to this angle here, which is angle OPR equal to angle ORP. Say equal to X. Angles opposite, equal sides. So I have X, this is X, and this angle is X. So in the triangle I have 3 angles, and it's equal to 180. So you have X plus X, and I know this angle is 160. So plus 160 equal to 180. 2x equal to 180 minus 160. 2x equal to 20. X equal to 10. And this is angle OPR equal to 10, which is also equal to angle ORP, which is also equal to 10. So I have now found out angle O. This is angle OPR. ABC equal to 69 and ACB is 31. Find BDC. So we start with triangle A, B and C. Now this is triangle ABC. And in triangle ABC, we have three angles, 180, that is 69 plus 31 plus A equal to 180. So 69 plus 31 is 100 plus A equal to 180. So A will be 180 minus 100. So A will get 80. So this angle A is 80. Now in the next step, we are going to do angles in the same arc. So we will take the arc B and D. And from B and D, I can draw two angles. One is here, and I have this angle. So this A equal to D, because angles in the same arc. So angle A equal to angle D, angles in the same arc. So angle, this is 80, so this angle also is 80. So angle D is also 80. And we know angle D is BDC, which is equal to 80 degrees. So just to go over it again, first we took this triangle, and in this triangle I have, this is 69 plus 31, and then we found angle A. So 69 plus 31 plus angle A is 180. So angle A we got as 80. So this got 80. And in the next step, angles in the same arc. This angle A, which belongs to the arc BC, and then you have angle D. Both these angles are equal. So this is 80. So angle A equal to angle D equal to 80. Angles in the same arc. ABCD are 4 points on the circle. AC and BD intersect each other at E, such that BEC is 130 and ECD is 20. Find BAC. So we're going to start first on this line BD, and we'll make a linear pair. This is a linear pair. So here you see there are two angles. One is BEC and DEC. Both these angles together add up, you get 180. So angle BEC plus angle DEC equal to 180. That is linear pair. So 130 plus angle DEC equal to 180. So angle DEC 180 minus 130. So DEC equal to 50. So here I got angle 50. Now in this next step, I'm going to take the triangle EDC. And this is EDC here. And in EDC, I have three triangles. EDC 1, 2, 3 equal to 180, that is 50, 20 plus this angle D equal to 180. So 70 plus D equal to 180. So D is 180 minus 70. So D is 110. So I have this angle D is 110. So this is the next step where we got D as 110. So in the earlier we got D as 110. Now we are going to use angles in the same arc. If you take up the arc BC, you have BAC, this angle BAC equal to angle BDC, the angles in the same arc, which means if that is 110, here also is 110. So you have angle ABC equal to angle BDC equal to 110. That is angle in the same arc. So in the first step we did linear pair. This was 130, so we got this as 50. Then in the second step we took the triangle. The two angles of the triangle were given. This was 30 and here was 50. Then we found this angle as 110, angle sum property. And in the last step, angles in the same arc, angle A, and we have angle D, are angles in the same arc. So if this is 110, here also will be 110. So angle A equal to 110. We'll now learn about a cyclic quadrilateral. Now it's a quadrilateral, hence it has got 4 vertices, and it is cyclic because the 4 vertices lie on a circle. So a cyclic quadrilateral is a quadrilateral where it has got 4 vertices, and these 4 vertices lie on a circle. So ABCD is a cyclic quadrilateral. Like every quadrilateral, it has got 4 angles, and there's a special property. This opposite angle A plus C is always 180. And you take the other side, D plus B will be 180. The opposite angles of a cyclic quadrilateral are always supplementary. The sum of the opposite angles. Sum of the opposite angles of quadrilateral is supplementary, is 180. The angles are supplementary, the sum is 180. So to repeat again, you have A plus C 180, and on the other side you have D plus B 180. ABCD is a cyclic quadrilateral. That means you have A, B, C, D all lying on a circle. So it is a cyclic quadrilateral. The 4 vertices lie on the circle. The diagonals intersect at point E. DBC is 70. Let's mark that. DBC is this angle and it is 70. And BAC is 30. Find BCD. Now, if you look at the angle BDC, it belongs to the arc BD, and here it is equal to angle, these two angles, angle A and angle B are angles in the same arc. So we write that angle DAC equal to angle DBC, that is angles in the same arc. So let me just go over it again. So we have here DBC, the arc is DC, and from this arc again I take DAC. So these angles are equal, so that is 70, this is also 70. So angle DAC is also 70. Now this full angle here is 70 plus 30, and that is 100. So angle DAB is equal to 70 plus 30, which is equal to 100. Now we know we have a cyclic quadrilateral, that is A, B, C, D is cyclic. So here we have cyclic, and in this cyclic quadrilateral, the opposite angles, that is A plus C, are equal to 180. So we need to write this. So quadrilateral ABCD is cyclic. Angle A, I'll just call it angle A, it's this full angle. We're talking about this angle here, that is angle DAB plus this angle here, that is angle DCB equal to 180. So DAB we know is 100 plus angle DCB 180. So angle DCB equal to 80. DCB can be also called as BCD, and that is 80. So BCD here is 80. The next part of the sum says if AB equal to BC, find ECD. And the next they have given us AB is equal to BC. If AB is equal to BC, so this is 30, this also will be 30. So let's write that. AB equal to BC. So if angle BAC will be equal to angle BCA. So if this is 30, this also will be 30, because they are angles opposite equal sides. Reason angles opposite equal sides. So we got angle ACB is also 30. But earlier we have proved that this entire angle is 80. That is angle DCB is 30. So we know angle DCB is equal to 80. And DCB is equal to, we will write this angle as x plus 30 equal to 80. So x equal to 50. Now angle x is this angle, and if you were to name this angle, it would be angle DCE equal to 50, or you could say angle ECD equal to 50.